the universe pixelated and blocky like Minecraft? And could a new experiment tell us the answer? Let's do some philosophy together. Hi, I am Glitch Hunter. I'm a computer nerd, and I love philosophy and nerding out and not taking myself too seriously. But there is one thing I've been thinking seriously about, and that is digital physics. This passion project has kept growing, and now I'm here with a YouTube channel and a book. This video is the first in a series of 6 where I deep dive into one question. Is the universe fundamentally pixelated? Is the universe fundamentally smooth and continuous with no smallest pieces at all? Or is the universe fundamentally discrete, like Minecraft? I think I might have stumbled on a way to test this, and I wrote a book about that called Atomism 2.0. It's pretty much open source and pay what you want. There's a link in the description. But this video series tells the same story, so let's begin. The core issue is this: blocky and not blocky are opposites, and the universe can't fundamentally be two opposing things at the same time. Or can it? This is a very old question. More than 2000 years ago in ancient Greece, there was a thinker named Democritus. He suggested two things. One is that everything in the universe might be made out of tiny pieces. And second, he thought those pieces were indivisible. He called them adomos. And that word comes from a, meaning not, and domos, meaning to cut. Atomos literally means uncuttable, something you can't divide any further. Fast forward 2,300 years, we now have a model of the atom. It has a nucleus of protons and neutrons with electrons around. And this model fulfills the first idea Democritus had of the atom, that it's what everything is made from. But not the second, because the atom can be split. In fact, splitting atoms is what made possible nuclear power and nuclear weapons. So the atom can be split into elementary particles, but can those be split? And what about the light particle, the photon? Can it be split? We don't know. So the real question Democritus asked remains open. We still don't know if there is a smallest possible thing. In fact, modern physics is kind of the opposite of atomism most of the time. Physics is all about particles and space and forces, but throughout this entire field, mathematics underneath treats everything as continuous. Particles are point-like, with fields around them, and everything is spread out in space, almost like a fog. People talk about particles as clouds of probability. So, modern physics seems to assume that the universe has no smallest piece at all, even when it has atoms. But not always. Einstein's famous E equals mc squared links mass to energy. So atoms can be turned into energy. And energy is also continuous, but when it's being transferred, exchanged, then it's discrete. Those interactions are discrete. So modern physics is a mix, sometimes discrete, sometimes smooth. It depends on the situation. But in all physics theories, space and time are treated as continuous. So what happens if we insist that we want to explore the opposite? What if space itself is just like your body, made from cells? Like Minecraft, just with smaller blocks. Really tiny blocks. Now let's do a thought experiment. We imagine the universe is fundamentally discrete, made from little cells, and we start zooming in on space itself, closer and closer. And eventually we would find there's no way around it, empty cells. In the discrete universe, there has to be a smallest block, similar to in an empty spreadsheet. This similarity isn't by chance, because a discrete space immediately looks and feels computery. This is because computers don't work with smooth continua, they only work with indivisible units, 0 and 1. Binary. That difference is called 1 bit. It is the difference between 0 and 1, same versus different, or true versus false, and it's the smallest distinction that any discrete system can make. So, in the discrete universe, empty space would be empty cells, and particles and matter and everything that exists would require that those cells were not empty. And as we just established, the minimum difference is 1 bit. So, in a universe of indivisible cells, the simplest possible model is one where each cell has just 1 bit in it. And that means describing reality using bits or information wouldn't be strange. It would be like the natural language of describing discrete universes. And it connects us back to Democritus and Atomism, because a bit is something that can't be split up any further. It is literally atomic, uncuttable. You don't need to know information theory to follow this. It's easy. Two things are either the same or not the same. There's nothing in between. And 1 bit is the difference between same and not same. This is where Minecraft and philosophy and physics meet. So, is there any evidence for this? Are bits and information theory showing up in physics and being useful? It is. Information theory keeps showing up everywhere in modern physics. It's actually not even that new. In 1989, John Archibald Wheeler, a famous quantum physicist, coined the term "it from bit." He proposed that everything, every physical thing like particles and fields and objects, the "it" of the universe, derives its function and existence from binary information theoretic bits, like the answer to yes and no question or true and false questions. And in quantum computing, this shows up again. Physical systems are being treated as information processors, and that sounds computery. In black hole physics, the holographic principle links information to the surface area of black holes. We don't fully understand what that means, but it works. So, is information just a powerful tool to describe things? And it can describe anything, so why not the universe? Or is it more fundamental, inviting us into a deeper layer of reality, hinting that space itself might be discrete, meaning space and time are fundamentally chunky? The answer to this question is, we don't know. We have no idea, no clue. But what we do know is this: modern physics mostly assumes space is Euclidean, that is smooth and continuous and behaving the same in all directions. But it also assumes that interactions between forces are discrete and information theoretic. There's something odd about this. I smell a bug or a glitch. Something is inviting us to look harder. If you want the full context, go to glitch.university and leave your email behind and get the book, Atomism 2.0, delivered directly to your inbox. But you don't have to. You can just watch these videos instead. And in the next one, we'll take the next step in this philosophical investigation. If we assume the universe is discrete, made out of tiny cells, what are particles? And how can they move around? And what does this have to do with chess?